Hello again. In this video, I'm going to show how to use NewGene to produce data sets with a distance variable. Now, scholars who study international relations are very familiar with distance variables. These are variables that capture the geographic distance between two countries, and also can serve as an indicator of whether two countries are neighbors to each other or contiguous. In NewGene, the distance variable group, which is open on your screen, uses a dyad year unit of analysis. So you can see it has country, country, year, which is a dyadic country year unit of analysis. And so what I've done here is I've selected country code 1, country code 2, the year, and then the capital to capital distance. This is the distance metric that is familiar to people who have used NewGene. This captures the geographic distance between two countries' capitals, or is coded as 0 if the two countries are contiguous neighbors. We also contain the minimum distance variable, which uses the C-shapes GIS-based measure of distance. But for this example, we'll work with the capital to capital distance. And so as you can see, these have been selected. Now, what we're going to do first is we're going to produce a standard dyadic data set. And so I'm going to run NewGene. It's going to produce this data set, and it's going to have the standard structure that scholars who have worked with distance data would see. So to do that, we have these variables selected. We're now going to click on the Prepare Run tab. You can see that I'm just going to produce this for 1 year of data, just for the purposes of illustration. And here in the output file, I've titled it NewGene Distance Example. That's going to be the name of the output data set. So with the output specified with my year set, I'm going to go ahead and click on the Generate Output button. You can see that NewGene is now producing the data. It's going to actually produce, here it's done, it's produced 13,526 rows of data. Now if I go ahead and open this CSV file, it's going to open in Excel. You can see that, as I mentioned, this is a fairly standard looking distance data set. You have C code 1, which the C code again is the cow country code. So for those of you who are familiar with the cow country code number 2 indicates the United States, 20 indicates Canada. So this would say the distance between Canada and the United States in the year 1990 is 0, the 0 indicating that they are contiguous neighbors. And we can scroll down through this data set and see that it's produced it for a whole bunch of countries, again, all for the year 1990, a whole bunch of dyadic or a variety of dyads. It's produced, indicates the distance between those two countries in the dyad for the year 1990. So this is how you could use NewGene to just produce a straight dyadic data set, again, for this 1 year. Now, suppose that we would want to produce this data set for a triad. Suppose, for example, that you want to work not with dyadic data, but with k-adic data. And in particular, if you would like to produce, you want to work with triadic data, where you would have country 1, country 2, and country 3. Well, in that case, we have to do a few things in NewGene that are a little bit different. So going back to the Select Variables tab, if the user wanted to produce a triadic data set, on the one hand, it would seem fairly straightforward that what the user would do is actually set the number of country columns to 3. Go up to the spinner, push the up button, and change it to 3. But what I'm going to do is show that that actually is going to produce an error. And I'll explain why it produces an error in just a moment, but I'm going to go ahead, I'm going to set this to 3. I'm going to go to Prepare Run. Again, we have this set for the 1 year. We're going to go ahead and use the same data set. Let me go ahead and make sure that the data set is closed. When I click on Generate Output, it's going to open up this window asking me, do I want to overwrite the file? I do, so I'm going to click on Overwrite, click OK. And what you're going to notice is right away it says Operation Failed. And it also shows total row 0 total rows. It then produces an error here. The choice of K in the spin control for DMU C code. Remember, DMU is the decision-making unit, and in this case, the distance data set is using country-based DMUs. Well, we set that spin control to 3. But as it tells you, it is not an even multiple of the minimum K value for the unit of analysis. In this case, it's 2. Because remember what I said was this is the distance measure, the distance data is dyadic based. Its base unit of analysis is dyadic. So what that means is we have to work with even multiples of that unit of analysis. In this case, since I want to produce a triadic data set, I have to actually set the spinner not to 3, but to 3 times 2, or 6. Specifically, if I go back to the select variables, I'm now going to set this to 6. When I set it to 6, I'm now going to click on Prepare Run. And again, I'm going to try to generate the output. Now again, it's going to ask me, do I want to overwrite the file? I do. So let me click on Overwrite. And I'm now going to click OK. Now you can see NewGene is starting to work. It's already generated 11, 12, 13%. About every second it's moving up. So it's probably going to take, a few minutes for it to be able to generate this output. So what I'm going to do is I'm going to pause the recording and then restart the recording once the data set is produced, and then I'll be able to show you the data set that was actually produced by NewGene. All right, so NewGene has now finished producing this triadic distance data set. Now, if you look at the status pane, what you'll notice is that there's been some errors. Specifically, you'll see this statement here, operation failed. Also wrote 0 total rows. Now, why is that? Well, the reality is NewGene was able to actually produce the requested data set. That was not the issue. The issue was this value right here. You can see is that because we had all countries that existed during that year, and we wanted to create a triadic data set for all the countries that existed during that year, NewGene estimated that it was going to have to create, let's see here, 100, 1,000, million, billion, over 400 billion chaotic combinations. Now, that may not have actually been what it was going to have to do. In fact, it is only an estimate. And NewGene will actually say as much. In fact, that's what it says right here. A quick estimate, but guaranteed to be the upper limit. So NewGene may not actually have to produce that many, but it's going to have to produce somewhere. It won't produce any more than that many. And indeed, that's what we see down here. Is it ends up not having to produce quite as many. But whenever we have an error like this means that basically it ran out of memory to be able to generate such a large data set. And this is not an uncommon problem when working with chaotic data. So what are we able to do at this point? Well, at this point, to be able to actually generate this data set, we may have to be able to generate a triadic distance data set. We may have to pare down the number of countries that we wish to include in this data set. To do that, I'm going to click off the simple mode check mark here. When I click that off, I'm now able to use you now see that the limit DMU tab appears. I can click on that. Then I can click on country code. And now you can see that I have a variety of country codes available here. So what I could do is I can go through and just select whichever ones I wish to use. In this case, I'm going to go ahead and use Austria, Belgium, and then Russia. Now, it lists here Russian Federation. Obviously, during the time period that we're looking at, specifically in 1990, 1991, it was not yet officially called the Russian Federation. That's just the indicator. The main thing to use here is 365 indicates that it's Russia, 211 is Belgium, 305 is Austria. So let's just create one using these 3 countries. Now again, as a A user could choose to add any other country they wish to. So, for example, we could click over here, click on Australia, click the arrow, and then we could add Australia to this as well. We're actually going to remove Australia from that. We're just going to use these three here. Now, when we do that, we need to come up here and click on this box, Limit DMU Members for the selected DMU category. So what this will do is this will now only generate it for these three countries. It'll generate a triadic distance data set for them. So we can now go to Prepare Run. We're going to leave the data set the same. We're now going to click Generate Output. Again, it's going to ask us, do we want to overwrite? We will say yes. Click OK. And you can see that it went ahead and produced this. And indeed produced just one total row because we only had the three countries. We're creating a triadic data set. So it just produced the one row. But this will help illustrate the kind of output that's generated. If we now open up New Gene, we can then look here and we can observe it. And we can see that what it did was it had country code 1, which of course is country 211, which was Belgium. Country code 2, which is Austria. Country code, and this is one dyad. Then it has the second dyad, which is from Belgium to Russia. Then it's the third dyad, which is Austria to Russia. And then what you can see here is it actually has three distance scores. What are those distances? Well, the first one corresponds to, the CC distance 1 corresponds to the first identified dyad, which is Belgium to Austria. You can see that that distance is reported as 568 miles. The second one is from Belgium to Russia, and that's recorded as just under 1,000 miles. And the third is from Austria to Russia, and that's recorded as 626 miles. So what we now have is we now have three distances for all the three members of this dyad, or for this triad, excuse me. So what we could do at this point is we could do a variety of things with this particular observation. We could, for example, delete some of these year columns because these are redundant. All of them are for 1990. We only need one of them. The other thing we could do is we could go ahead and delete the redundant values for Austria and for Russia. So that way we now have a very clean looking data set. We could rename this C code 1, C code 2, C code 2, C code 3. Rename that year. And now we have a fairly clean looking observation here. We have Belgium, Austria, Russia for the year 1990. That is the distance between the first two members of this triad. That's the distance between the second two members of the first member and the third member. And then this is the distance between the last three members. And then at this point, we could generate some sort of overall distance metric if we wished. We could, for example, record the max for these three, the max between E3, E2, F2, G2. So, and maybe that is the distance value we wish to use for the entire triad, right? We could say triad distance. Or maybe we wish to use the average. Maybe that's not what, maybe we don't want to use the max. Maybe we want to use the average to represent the triad's distance. Any number of these we could use. We could use the minimum. We could use any metric that the user wishes to use. But what I've shown here is how New Gene can at least generate these data in a triadic format. To summarize, the key things to keep in mind is that you'll have to work with even multiples of whatever size CAD you wish to generate. And the other thing you'll have to keep in mind is that you may have to limit the number of variables that you, or the number of units for which you wish to create such a chaotic data set. Again, you saw that when we're dealing with the dyadic, which is just as one would generate using Eugene, there really wasn't much of a problem. But once we start moving into a chaotic framework, the data issues, the memory issues become much more challenging for a computer. Thank you.